testing the hypothesis, first state your null hypothesis. Then our null hypothesis is there's no significant relationship between the student scores in the two subjects. Then compute for the tabulated value of R. In getting the tabulated value of R, degrees of freedom equals n minus 2. So our n equals 10. Then minus 2 equals degrees of freedom 8 at one-tailed test at 1% level of significance. So our tabulated value of R is 0.715. Next. This is the number of student, which is our n, and this is our math score, which is our x, and the English score, which is our y. Next, compute for the x squared. In getting the x squared is 34 times 34 is 1156. 23 times 23 equals 529, and so on. Then get the y squared also. In getting the y squared, 12 times 12 equals 144. 8 times 8 equals 64, and so on. And get the product of the x and y. For example, 34 times 12 equals 408. 23 times 23 equals 148, and so on. The next, get the total. N equals 10. Then our summation x equals 194. Our summation y equals 186. Our summation x squared equals 4276. And our summation y squared equals 4594. Our summation x y squared equals 3744. Next, compute for the computed value of R with the formula R equals square root of n summation x squared minus summation x of squared times n summation y squared minus summation y then squared divided by n summation xy minus summation x squared times summation y. Then next, substitute. Then we get the answer 0.22. So our computed value of R is 0.22. So we accept the null hypothesis because the computed value is less than the tabulated value. So our conclusion is, therefore, at 1% level of significance, there is no significant relationship between the student scores in the two subjects. The null hypothesis. So our null hypothesis is there's no significant difference for the 4 programs for training workers to perform a certain manual task. Then state the tabulated value. Our tabulated value of R is 5.29. Then this is our program 1, which is our x sub 1, and the program 2, which is the x sub 2. The program 3, which is the x sub 3, the program 4, which is the x sub 4. Next, get the squared of x sub 1. For example, 9 times 9 equals 81. 12 times 12 equals 144, and so on. Next, get the squared of x sub 2. For example, 10 times 10 equals 100. 6 times 6 equals 36, and so on. Next, get the squared of x sub 3. 12 times 12 equals 144. 14 times 14 equals 196, and so on. Then compute for the squared of x sub 4. For For example, 9 times 9 equals 81, 8 times 8 equals 64, and so on. Total for this summation x sub 1 equals 51, for the summation x sub 2 equals 44, for the summation x sub 3 equals 61, for the summation x sub 4 equals 43, for the summation x sub 1 squared equals 711, for the summation x sub 2 squared equals 398, for the summation x sub 3 squared equals 751, and for the summation x sub 4 square equals 379. Then get the squared of the summation x sub 1, sub 2, sub 3, and sub 4. The squared of summation x sub 1 equals 3,481, and for the squared of summation x sub 2 equals 1,936, and for the squared of summation x sub 3 equals 3,729, and for the squared of summation x sub 4 equals 1,849. Then note that our R is 5 and our C is 4. The R represents the row and the C represents the column. And remember also the summation times summation x squared is equal to 2,239, and for the summation times the squared of summation x equals 207 squared is equal to 42,849, and remember for the summation times summation x squared equals 10,987. Next, compute for the SS sub t. In getting the SS sub t equals summation times the summation x squared minus summation times squared of the summation x divided by RC, and then substitute. Then the answer is 96.55. Next, solve for the SS sub c equals. For solving for the SS sub c equals 1 divided by the r times the summation times the squared of summation x minus summation the squared of the summation x divided by RC, then substitute, then the answer is 54.95. Next, solve for the SS sub w. For solving for SS sub w equals SS sub t minus SS sub c. So our SS sub t is 96.55 minus the SS sub c 54.95, and the answer is 41.6. Next, solve for the degrees of freedom sub t equals RC minus 1. So 5 times 4 minus 1, the answer is 19. Solve for degrees of freedom sub w equals c times r minus 1. Then 4 times 5 minus 1 equals 4 times 4, then the answer is 16. Solve for degrees of freedom of c equals c minus 1, then equals 4 minus 1, then the answer is 3. Solving for the MSS sub c equals SS sub c divided by the degrees of freedom sub c equals 54.95 divided by 3 equals 18.31. Then solving for the MSS w sub w equals SS sub w divided by the degrees of freedom sub w equals 41.6 divided by 16 equals, the answer is 2.6. Then solving for F sub c equals MSS sub c divided by the MSS sub w equals 18.31 divided by 2.6 is equals, the answer is 7.04. 7.04 is our computed value of R. So our computed value of R is 7.04. We reject the null hypothesis because the computed is greater than the tabulated. So our conclusion is, therefore, there is a significant difference for the 4 programs for training workers to perform a certain manual task. That's all. Thank you.